we're doing math induction, and some of these look a little scary when you start doing something other than adding terms. Because I think, did you do this one? No, we didn't do this one in class, did we? But we did some similar to it. But this one here, if you do the 3 steps, n equal to 1, n equal to k, n equal to k plus 1, you can build this up pretty quick. So 2 to the 1 minus 1 is equal to 2 minus 1, or 1. Is that equal to the first term? 1? Yes. Therefore, true for n equal to 1. That step okay? All right. Then for n equal to k, the step looks like this. 1 plus 2 plus ... 2 to the k minus 1 equals 2 to the k minus 1. You might think that's annoying, but this is our assumption step that's going to help us substitute in making things simpler. All right, so the next one, n equal to k plus 1, you write everything the same. And then you add the next term. 2, in place of k, you put k plus 1. Well, what's k plus 1 minus 1? K. So that's convenient. And then you're going to get on this side 2 to the k plus 1 minus 1. This one is actually way easier, but it just bugs you because of the exponents, right? This whole part here can be replaced with what? 2k minus 1, right? This is my assumption. I can replace this with 2k minus 1. And then this red part is just 2 to the k. This guy here, this is something you probably struggle with. What's 2 to the 3rd times 2 to the 4th? What is it? How did you get that so fast? Oh, you add the exponents. Do you agree with that? Because you have 3 of these and 4 of these. So 3 plus 4 will give you 7, or just add those exponents. So you don't have trouble doing that, do you? Then why do you have trouble going backwards? What's this equal to? 2 to the x times what? 2 to the 1st. Because if you saw this, you'd go, oh, this is 2 to the x plus 1. But for some reason, going backwards is annoying for you. So let me show you a little trick that I like to do. Is when I see this 1, I like to say, how many 2 to the x's is this? How many 2 to the x's is this? 2. What if I had 2 to the x plus 2? How many x's would that be? How many 2 to the x's is that? 2 to the x plus 2 is how many 2 to the x's is it? 4. What if I had 2 to the x plus 3? How many x's would that be? 2 to the x's is that? Now it's what? 8, right? Does that make sense? Now, what if I had x minus 1? Now, how many 2 to the x's is that? Well, half, isn't it? Does that help you a little bit? So when you see that 2 to the x plus 1, think of it as how many 2 to the k's or 2 to the x's is it? So this has how many 2 to the k's? 2. That might clarify it a little bit. Now I'm going to subtract 2 to the k from both sides. And now, if I had 2 to the k's and I subtract 1 2 to the k, what do I end up with? 2 2 to the k's minus 1 2 to the k is? I know it's Friday. 1 2 to the k. And then on this side, these will cancel out, giving me 2 to the k minus 1. Did I show that the left side equals the right side? Therefore, true for n equal to k plus 1. So then we did the big therefore statement, since true for n equal to 1 and n equal to k plus 1, the equation, and I'm going to even say the sum equation, is true for all n greater than or equal to 1 by scary math induction. Keep recording. This is the other one students always ask me about. By math induction, prove n cubed minus n is divisible by 3. Now you got to be careful here. This is a tell for step 1. What's different on this one? What do we start with? N equal to what? Start with 2, yeah. And they're whole numbers apparently, because we're talking divisibility by 3. We're not talking all real numbers, we're talking integers. So if we start with 2, let's see if 2 plugged in is divisible by 3. So 2 cubed minus 2 is going to be 8 minus 2, which is 6. And that is a multiple of 3. They should, somewhere it should say integers. Yeah, this is, I bet I did somewhere, or maybe I didn't put it in there. Then, this is important for step 2. Are you ready for this? What do we do in step 2? You just let n equal to k. So now you just have k cubed minus k is divisible by 3. Now let me help you with divisible by 3. Just say n times 3. Okay? N times 3. Because, and we can say where n is an element of the integers. Mm-hmm. Okay, so going back, we did n equal to 2. We plugged that in because n is greater than 1. We use integers. It's going to make it work. 6 is a multiple of 3. So then n equal to k is this. This is going to be my assumption. And I won't abbreviate it. Or substitution for later. You're going to use that. Guaranteed you're going to use it. So then for the next step, let n equal to k plus 1. Now what you're going to do is wherever there's a k, you put in a k plus 1.
Should we write out the steps when we do it?
Sure.
Step 1 equals.
Oh, that's not important to me. That's fine. Might be easier to follow for you. Now, does that k plus 1 cube scare you a little bit? Binomial expansion. It's a little yucky, but we can do it. We can do it. So this is k cubed, k squared, k to the first, k to the 0. Then it's 1 squared, 1 cubed, so plus 1. And then for the binomial expansion, does this remind you of anything? It's up on the wall, too. I call it Pastel's triangle, just to be cute. Oh, yeah, we talked about this, didn't we? So this will be 1, 3, 3, 1. And then don't forget, this is minus k plus or minus 1. Careful. Minus 1, yeah. We'll lose the 1s, which I'm happy about. And you'll end up with k cubed k cubed plus 3 k squared plus 3k.
Yeah.
Oh, 2k, yeah. Needs to be a multiple of 3. Does this look like a multiple of 3? Not even close. Ah, got it. I don't know if we can do this. Anybody have any ideas? No ideas? You got an idea? Yeah?
Change the 2k to 3k minus 1.
Okay. See how I did that? All right, so sorry about that. 3k minus k is definitely good. And now I'm going to highlight something. Whoop, that's called crossing out. Let's highlight. That doesn't work. And that doesn't work. That's okay. I'm highlighting that. Turn to your neighbor. Tell him what that's going to enable me to do. What's k cubed minus k is we can substitute for n3. So wherever you have this, k cubed minus k, I'm going to write it together if you don't mind. I know it's an extra step, but it'll look a lot better when you're studying it. Multiple of 3. So this can now be replaced from our assumption statement of n times 3. And what do you see now? What do you see? It's all divisible by 3. So now we can say, therefore, true for n equal to k plus 1. A little clever problem, kind of cool. Use that substitution. You need to get that. And we couldn't have done it without Kurt because he changed that 2k into 3k minus 1 so we could mine out that minus k. That's good. And then we substituted these from my assumption statement. And now everything has multiples of 3, and we're good to go. And then don't forget the big therefore statement. I won't write it out at this time.